Okay, today I'm going to show you how to design a little PCB adapter, a nice little professional PCD adapter for whatever your project is. I do a lot of arcade projects, so often I will design replacement, very simple adapters, and for parts that maybe are obsolete or they're hard to find, I design things so we can use newer parts in place of them. So this is, I'm going to do a very simple design. A lot of people like to replace 4116 RAMs with 4164 RAMs because they're more reliable basically. They only use two voltages, well, one voltage really, ground and plus 5, so that's one voltage, as opposed to plus 12 and negative 5 and plus 5. So a lot of people like to replace them, but I don't like to hack up boards, which is one way of replacing them. So I designed a little just adapter that goes in between them. So I'm going to show you how to do that with Eagle Cad software. Now before I do this, I have to tell you I am not a professional. I do not design circuit boards for a living. I've only used Eagle a handful of times to design 4 or 5 very simple boards, so I might be doing things wrong. There might be better ways of doing things. Certainly, if you're interested in this program, you want to go out and probably learn more about it if you want to design boards. But I'm just going to show you very simply how to design a board very quickly with Eagle Cad. So how do we do that? First, we have to get it. So the easiest way to get it is go to Google and Google Eagle Cad, and it should probably be your first link. It's maybe the second link here. It says Eagle PCB Design Software. Click on that one. Download Eagle. Free download, blah blah blah, go through the process. I'm not going to show you how to download and install it. I'm just going to show you there. That's how you get it. You can click around, put in the information, download it, and install it on Windows, Linux, or Mac. Once you have it up, which I already do, bring it on over. You want to create a new project, so we'll do new project, give the project a name. We'll call it 4116 to 4164, and then you're going to right click and do new board. Okay, and this brings up the board, and usually I think by default on this version the where is it, user interface, I think is black, and I don't like that. So I go to the user interface and I do user interface. I'm going to turn it to white. Okay, and then I'm going to turn the grid on. So just click on grid, and you can set the grid whatever you want, millimeters, inches, and whatever multiple you want within reason. I'm just going to set it to millimeters. I don't know. That's fine. I don't care. And oops, and it didn't show up. Where is it? Oh, got to turn it on. Turn it on. And okay, and then we get a little grid. Now, this is just my opinion. I think it's hard to use until you actually set up the diameter of the board. You may not know what the diameter of the board is, or not diameter, the dimensions. This right here is your origin. Now, with the free software, apparently I think you can only use positive from this origin, X and Y, and you can't put anything anywhere in the negative. Now, so and with the free version, I think you only can have something 100 millimeters by 80 millimeters or something like that. I don't know. That could be wrong. It's something like that. I don't know. So what I like to do is I like to just set the dimension. So what I'm going to do here, I have it on millimeters. I'm going to go to here because you have a bunch of different layers when you are designing a PCB, and you'll see that. But just go and pull down dimension, and then draw a line. So I'm going to set mine to the maximum that I can draw, which is 100 by 80. I get my designs from somewhere called seeedstudio, and they have a really good price on designs that are 100 by 100 millimeters or less. But I can't even draw 100 with Eagle with a free version. So I'm just going to draw it 100 by 80 millimeters. So look up at the the top, it's showing you as I draw it, as I drag it, it's showing you the access. So I'm going to do just under 100. So 99.06. Hit the button. I'm going to go up to as close to 80 as I can get, which is there, 78 point whatever. Go back to 0. Actually, I'm just going to close it there, and then I'm going to go back to the origin and go up to as high as I can go without going to 80, and then complete it. And now everything gets grayed out, and this is the usable area. Okay, so I want to lay out a board now, or a little adapter. So again, I'm going to be designing a 4116 to 4164 adapter, so I need to know about that chip. So I'm going to pull up Chrome, 4116 pinout, 4116 there, looks good. And then I'm going to do another tab, 4164 pinout, and that looks right. So now I'm going to, I just want to put them side by side. Nope, that's not what I want. I want a 4116. How did I get that? I didn't get, that's not 416, that's 4164. 4116 pinout. Alright, so I'm going to put these side to side, and we can actually get back to this later. But what I need is 1, 2, 3, 4, 5, 6, 7, 8. I need 2. They're both the same number of sockets, so I need 2 16-pin sockets. So I'm going to go now to Add, and I'm going to just put socket in here, and I want a 16-pin socket. So I'm just going to scroll down until I find 16-pin dip dual inline socket. Here we go, socket 16. Alright, click OK. And now I'm going to place this on my board. And if you, hit Control Z to go back. That screwed up. Let's do that, add again. So, double click, OK. And now, if you want to rotate it, which I do, you right click. So I want to do that, and I want to put it, I'm going to put it just a little bit in. That should be good right there. Actually, I like to give a little space in case I want to route around, but I don't need to do that. But all right, so I put one there, and then I'm going to do another one, just about as close as I can get, because this is a very simple design. Most things are going to go straight from one pin to another. Okay. All right, did that. I'm going to click on the I button for info, and the right side, the left side is going to be my socket, or my pins that would be the 4116. So I'm just going to click on it, and then I'm going to click on populate, because that should take care of the silk screening, so I can see that easier. Then I'm going to go to I again, click on this, and I'm going to give it a name rather than $2. I'm going to call it 4164. Okay. All right. Now we have to figure out how these guys go together. And so what we'll do is, I'm just going to put up in the corner the two designs. Oops, that's not what I want. The two chips, I'm sorry, not design, the two chips. And what we see here is almost all the pins are just going straight from one to another. +5 is not. The +5 on 4116 doesn't go to anything, so we're actually not going to connect anything. G and D is ground, VSS is ground, CAS is the same. This is actually D out, and Q is the same. A6, A6, A3, A3, A4, A4, A5, A5, and A7, and A7. Or I'm sorry, 5 volts and A7. So all the these top 7 are just going to go straight to each from one to another. So what we do is we get this thing called signal, and we click. We want the top right from this. These are the pins. This is the rightmost pin on the 4116. click on that and click it over here, and then click again. And I'm going to do that for the top 7 because those things are directly the same. They should all go to the same. And the last one does not, because the last one is not the same. It's on the 4116 it's +5, and on the 4164 it's A7, and there is no A7 on the 416. Now we're actually going to be able to just run it directly there too, but we'll talk about that later. So let's get the other things we know about. DN and D are the same. This is the same. RAS and RAS are the same. So all these top, except for the first one, the next 1, 2, 3, 4, 5, 6 are the same. So let's just skip the first one and just go 1, 2, 3, 4, 5, 6. Now nothing, let's go back to these. Nothing, +5 doesn't connect to anything. And on here it's NC, not connected. So we're not going to even connect those two. We're not going to do anything with either of those. So that's done. +12 also doesn't go into anything on the 4164. We don't actually want to connect this pin because this is what's coming from the motherboard if it's strapped for 41116s. We don't want that going anywhere. So we're not going to connect anything to this pad. However, on the 4164, that's +5, and we need that. Now, on the 4116, +5 is pin 9. So what we're going to do is we're going to connect pin 8 on the, pin 9 on the 4116, which is this guy right here, to pin 8 on the 4164, which is this one right here. So this is pin 9, which is +5 coming from the board on the 416, going to pin 8 on the, did it go? I don't think it made it, did it? On the, what would be the 4, there it goes. Alright, 4164. Now, that's fine, but, and we're almost done, but we need now to actually do something about this one. On the 4164, there's actually more RAM addresses, and we want to make sure we don't want this ever, we don't want it floating. It has to be either high or low. It's not going to be used, but by setting it to something, it's like neutralizing. It's not there. We can set it to ground, or we can set it to +5. Since we have +5 already here, right next to it, we'll just move that +5 right there. All right. So I think we have all the connections now that we need, and now we have to actually tell the board to route them. So we're going to click on this right here and make sure it's the right thing. Nope, we want auto router right here, auto router, and it's actually going to try to figure out how to best route these wires. And since this is a very simple design, it's going to just work. There's options here on how it should try. It's actually a fairly complicated process normally, but we're just going to continue because this is going to be a super simple design. And then start. And it did it. Okay, so now that I've drawn that, what I can do is I could either copy all this to the and just fill up the space, because my PCB fabrication house that I use gives me all the space to use. Or you can just, if you don't want all that space, now that we know the space that we do want, you can delete the dimension. So what I'm going to do is I'm just going to draw a line. I'm going to draw from where I want it to end, the top and at the bottom, and there. Now it cuts that off. Okay, so now I'm going to delete these dimensions, and I have a board. Now I can send this to the fabrication house and get it fabricated. One thing I actually like to do is I like the power rails to be a little thicker. So I just go to Info, click on the rails there and set the width to something a little bit bigger. Let's double it. We gotta do double both sides of it. Okay, save it. Now we're going to want to actually save this to a file that we can upload somewhere. So we're going to go to we have to do, it's called a CAM processor, and you can actually look as you click on the CAM processor. You can look at that, what it looks like. This is the top copper, bottom copper, profile, solder mask. If you had some silk screening on it, it actually silk screened the name of the one thing. I don't know how to get rid of that. I have to actually look that up. And what we're going to now do is we're going to go ahead and just export it. So we're going to export as a zip, and there's the file name. It's on CAM outputs, Gerber files, copper, process job. Okay, save it, and I'm going to open the folder, make sure it's there. Okay, it looks good. Now I like to go to seeedstudio, and that's where I get these things made. There's also Park, which is in the United States, and it's fast, and it's pretty cheap. If you want to just like a prototype run, Park I like to use. So now we go to seed, that's 3 E's, studio, and we want Fusion PCB manufacturing. So click on that, and then just fill it out. You add your Gerber file, which is a zip file, and that's the file that it created. So we have to go and actually find out where it was. Eagle, was it? Projects 41162, that, and it's a zip file. It added today's date on it. I didn't realize that. So upload your file, and you can actually choose the viewer now to make sure it looks like you expect it to look. And there it is. That's what it looks like. You can choose the top, the bottom, overall. Alright, make sure it's what you expected. And then you choose your 2 layers. The dimensions are there. How many you want. 10 is the best deal. It's weird. It's like $4 for $4.90 for 10. If I go to 20, it goes to 44, which makes absolutely no sense. I double it and it costs 10 times more. So I just order a bunch of 10s when I order them. I have no idea why it does that. It's only got one design. PCB thickness, you can use the default. I actually like to fill up the whole space, and then I use a really thin design because then I can cut it with scissors. If it's a small design, for example, this thing you could probably get 12 on a board of 100 by 100. So save yourself a lot of money. You get 12 for each board and 10, so that's like 120 adapters. You choose your color. You can't actually go to 0.6 without adding a lot more money. Choose your color. Everything else should be fine. Okay. And then you just go through, add it to your cart, and go through the process. And you get yourself a nice set of really professional boards. Pretty cheap. So I'm going to add this for my Patreon people, the actual files, the Gerber files, I'm going to add so you guys can download. So YouTubers, sorry, you got to design it yourself. But if you are a Patreon viewer, you can download the file and then just get it created. Now, that said, I wouldn't do that yet because I actually haven't got these in and tested to make sure they work. But theoretically, they should. All the things I lined up should work correctly. All right, that's it. Thanks.